Okay, welcome to the March 25th session, 2025 session of TAPR and HamSCI technical session. My name is Dave, KB0S, and this week I've been putting together my kit to go to Hamvention, make sure the different pieces are working. So we have some demos for the booth. And I've been doing some 3D printing, so trying to get a few things fixed. So that's it for me. Next on the list is Nathaniel, W2 and AF. Go ahead.
Thanks, Dave. I've been continuing to follow up on things since the HamSCI workshop. We had spring break last week. Classes started again today. Two things I want to do tonight. One is my student Tom Pisano, KE2BAC, is on the call, and he's very interested in developing a interface to HF radio for people who are blind and visually impaired. And we started having some discussion about that with Phil over at the HamSCI workshop. And we wondered if we might be able to take some of the open session time to continue discussing some of those ideas with Phil and with other people on the group. And the other announcement is that we're working on this meteor scatter QSO party, and maybe Gary AFA might be able to talk a little bit more about that later in the call. But one of the things we're looking for is someone to be the chairperson, the community chairperson, to do all of the organization of the amateur radio operators and things like that. And Gary did that for the solar eclipse QSO party, and he did a fantastic job. But we need someone to do it for the meteor scatter QSO party too. And so we're looking for someone with a dynamic personality, good experience in amateur radio, lots of great organizational skills, copious amounts of free time, lots of energy and vim and vigor. And I'm sure Gary can say if I left anything off the list. But if you know somebody and that might be interested or might be a good candidate, please let us know. So back to Net.
Okay. And next on the list, I didn't pop up my list here. Dave, KD0 EAG. Go ahead, Dave.
Oh, hello. I've been, I don't know, not a lot of excitement, testing some little UPS intermediate level power interruption preventers for small computers and devices. See if there are any of them I like the behavior of. That's been my thing today. Otherwise, not a lot of excitement. You take it from there, I guess.
Okay. Next on the list is Jim, K4BSC. Go ahead, Jim.
Good evening. Not a lot going on here. I've been trying to redo some of the audio pads in my ham shack. I had two sets of speakers, one for the computer and one for the radios. And speakers were taking up room I didn't really want to give to them. So I decided to try combining them. And I bought a very, very small mixer. And I've got signals from the radios and the computer running through that now to a single set of speakers. It's working. I've got some cleanup left to do. Not a big project, just a little one. Got another little lighting project on the bench I'll get to tomorrow, but not anything exciting. Back to Net, K4BSE.
Okay. Next on the list is Clint, K7OEI. Go ahead, Clint.
Hi, don't have my camera set up right now. Working on a 2-meter direction finding unit for a friend, and so I'm kind of multitasking and listening to what's going on. Back to you.
Okay. Next on the list is Bob Strickland. Go ahead, Bob.
Hello, everybody. I just got here a little bit late, sorry, and don't have a lot to report this week. Just back to you, Dave.
Okay. Next on the list is Dave Julian, WB9YIG. Go ahead, Dave.
Hello, folks. Yeah, just not much going on here. I did mention earlier that I monitored the meteor scatter Saturday morning. Just left the radio on, and I copied about 5 or 6 different stations. So I was tickled pink to see that, but I was a little bit late getting to the radio to actually try to work anybody. But I was tickled pink. That's an EM68 on a 80-meter loop. So that's all I got. Back to the net.
Okay. Next on the list is, let's see, Dave W6OQ. Go ahead, Dave.
Yes, good evening from Southern California. I'm here to see what I can learn. Thanks.
Fine business. Next on the list is David McGaw in one HAC. Go ahead, David.
Good evening, everyone. The most exciting thing here is we got snow back after we got about 3 or 4 inches of wet snow. So back to winter. But we had a nice talk with Pierre VE3KTB up at Eureka Station on Ellesmere Island, comparing notes on polar operations and whatnot. The thing I got out of it, perhaps most, was that we all have problems with critters and cables. He not only has foxes, which was my problem in Greenland, but they have wolves that yank cables out of the wall and connectors out of radios. So I guess I should feel grateful that I only had the foxes. But we also got a hot tip on what to put on, and now I can't remember what it was. Do you remember, Nathaniel?
I'm sorry, a hot tip to put on what?
The stuff that we got a tip on what to put on cable so that the
Oh yeah,
critters
yeah,
wouldn't
yeah.
chew 'em.
Uh, I'll tell you in a minute.
Yeah.
I looked it up. It's something green junior, the pain medicine.
Yeah, it was something or other.
Yeah, no, I have it. I'll put it in the chat.
But yeah, I will also mention that I do know you can actually buy cable with Cayenne in the jacket.
Okay.
Oh,
But
Abercine Junior, I think.
Absorbing Junior is
Absorbing Junior, that's what it
Absorbing
was.
Junior.
Yeah,
Okay.
it has wormwood in it. They don't like that.
Absorbing Junior.
huh.
So anyway, hopefully all this white stuff will melt off in the next couple of days. But we are definitely in what I call yo-yo weather. Oh, the other thing is we did actually have some aurora a couple nights ago. We unfortunately had a cloud to the northeast, kind of right in the way, but could definitely see the glow and did see a few pictures of it. But it really affected propagation such that the next day, 20 and 25 megahertz WWV were just not there until actually very late in the evening. They popped in finally. But it's kind of a puzzle to me why the higher frequencies would disappear under those conditions and recovering from a geomagnetic storm. But maybe we bring that up at the science meeting. Back to net.
Hey, one question. Aren't you probably among all of us here closest to the impending next eclipse?
Oh, the one on Saturday morning?
Yeah.
Yes.
So hopefully you'll get
Yeah,
at least
it'll
a partial.
be halfway through. It'll be right about the peak of the eclipse just as it's rising. So I got to find a low horizon to the east.
Yeah. Very good.
Yeah, if people aren't aware, there actually is a partial solar eclipse Saturday morning that
Supposed to
those
be
of us
best,
in the Northeast
best
should
in
be able to catch
Labrador.
glimpse of.
Yes. Okay. Next on the list. Let's see. Oh, Elmer. Elmer, it's your turn.
Oh boy. Most of the week I've been spending on N6GN's antenna system, trying different variations of it, modifying circuits and things like that. And I was also then, because I had boxes I had printed outside for some period of time, opening them up and inspecting to see how they were doing in the weather. I get kind of icky weather here for quite a while at a time. It rained again today, and hopefully I'll get a couple hours outside tomorrow before the next rain comes through. But trying different antenna concoctions on the roof at this time. So that's me. Back to that.
Very good. Next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. I'm trying to stay busy, keep out of trouble. Many of you might have seen on our Google group that the most of the presentations and the posters from the workshop are available from the workshop website on hamsci.org. So that's good. I just posted the announcement on the HamSCI homepage for the Dayton Xenia Hamvention. So we've got a lot of information there. We've got to wait for the Hamvention organizers to give us the final details on our forum location and whatnot, which you guys were talking about the TAPR forum earlier. So along those lines, so that'll be coming out. And Nathaniel's point about the meteor scatter QSO parties were good ones. I also want to say that we don't expect anyone to grow this thing entirely from the ground up. There's been a group of people from HamSCI who've been contributing a lot of good information. We've got checklists. You know, we're starting to get this whole thing together, but we kind of need the big kahuna, the big cheese at the top to pull it all together and to keep things moving between now and the meteor showers in August and December. So that's it. Back to net, Dave.
Okay. And next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I was quite busy this past week working on the VLF preamp circuit board and bill of materials in KiCad. I entered in the part numbers and other information into the schematic, and I formatted it so it produced a readable bill of materials. So I'm still kind of learning KiCad, but I was able to get it where it produced a pretty usable bill of materials. And then I started with the board layout. I figured out how to do the board outline, which you basically pick the board outline layer, and you set its size, which I did, and then I worked on laying out or placing the footprints. I could show you quick. I did pretty well, or you know, at least I tried. So this is what I was working on. This is the preamp board. It's very narrow because this is supposed to fit inside a PVC pipe. You can see here, this is the connection to the antenna, and this is the calibration transformer. This is actual interface. This is a screw terminal connector for injecting a calibration signal. Some more of the circuitry here. This is the DC to DC converter. This is the auto isolation transformer. This is the screw terminal connector where the feed line connects, and this is where the ground connects. Technically, what this is it's basically like a grounded dipole, basically. Kind of what this is. But so at this stage of the game, I'm kind of happy with how I got it, and then now I just have to work on doing the traces, and there's also going to be portions of the board that are going to have a ground plane. So what I'm trying to mimic, at least, is the this is an image of Paul Nicholson's his preamp board that he had built for the ILDN, the Indian Lightning Detection Network. So this is the preamp board that he actually built, and it's his circuit that I'm using for the ILDN VLF active antennas. So each ILDN site is a VLF reception system and a Raspberry Pi, and it's sampling the VLF spectrum. It's looking for spherics, specifically propagation information about spherics, which 10 sites feed back to a central server where it actually computes the lightning strokes. But this preamp is used, or this circuit is what I built for the system that's currently running right now. So I'm trying to mimic this because it's definitely it's a working design, and it works quite well, and it's a fairly simple circuit. All of my part, I've chosen through hole parts footprints to make it easy to repair, rather than surface mount, even though that I can make it smaller. But anyway, I've been working on that, and I'm kind of happy with the progress that I made. Lastly, I've been working with Kung, and I've been giving him information on VLFRX tools and the data format, because he's working on a converter to convert from VLFRX tools format into digital RF. So I gave him some example files and some information on how to use VLFRX tools. So I'm working with him to make it happen. The way that I think that it's going to happen is it's probably going to be that the VLF spectrum data, which is basically recorded PCM data with a timestamp on each sample. There's a utility to convert that format into ASCII text, which gives you a column for a timestamp and a column for an amplitude. And from there, that would probably be the easiest way to convert to digital RF, which I think that's how Kung is going to do it, at least for now. And lastly, one thing that I wanted to mention, I know that Bill isn't here, and Michael isn't here either, but I wanted to kind of discuss further the how we would ingress all of this VLF data and how we would visualize it, process it, display it, store it. There's still some things that are or well, there's a lot of things that are up in the air. Nothing's really concrete yet, especially with getting the data to the personal space weather station server run by Bill, and also what kind of data products that we're looking for. I have some examples, 2 websites showing that will show not only traces of VLF transmitters, daily traces, but also thumbnail spectrograms and full-size spectrograms and audio samples of captured natural radio events like dawn chorus and whistlers. And I think that would be a useful thing to have for people to access for these VLF systems. So I wanted to discuss that further, but unfortunately, it looks like they're not here. So we'll just but if anyone is willing to discuss that tonight, I would be happy to. That's all I have. Back to the net.
Okay. Next on the list is Phil, K9Q. Go ahead, Phil.
Okay, yeah, find the button there. Not really much to say. I just got back from Baltimore last night, and I'm still pretty tired, so I won't say any more. Back to the group.
Okay. Next on the list is Scott in 5TNL. Go ahead.
Hey everybody, no progress, but lots of confusion last week. For example, I'm looking at one of Elmer's CHU wave files that has obvious missing samples, yet I didn't detect that while I was recording it, and I don't understand why. So that's kind of bothering me, and that's it for me.
Well, I'm glad you're looking into it. So next on the list is Thomas, KE2BAC. Go ahead, Thomas.
Yeah, hi everyone. It's really nice to be here. I appreciate you guys having me at the meeting. I am, excited to learn a lot about all the different projects everyone's working on, and I'm also really excited to get some input on the project that I am working to start with Nathaniel. So it's nice to be here, guys, and I'll send it back to Net.
Okay. Next on the list, we have Tom in 5EG. Go ahead, Tom.
Okay, good evening, Dave. Everyone in the group, not too much to report to about. I just finished moving and everything fell apart, and I will now start the inverse moving process. So it's going to be painful. I'll be out of commission for a little while. Back to the group.
Oh, okay. And I see that Michael Howen jumped in there. So your ears must have been burning. People were talking about you.
Oh boy.
Go ahead.
Well, I'm just what am I been working on a variety of different things. I've got some network problem here at home, which is annoying the hell out of me, interfering with transfer of spots and such. But the antennas that I'm using are still up, thankfully. I've continued to be given some thought to the WWV, WWVH frequency discrimination issue. Phil has provided me with pointers to higher quality information about the timing of the worrisome tones on 100 hertz. So I may be able to incorporate that in. The problem is that it takes 10 seconds of tone to resolve to a level of about 1.1 hertz. So if the tones that I was listening to were 40 seconds long, which enabled me to get some more accurate determinations of what the frequency was of the 500 and 600 hertz tones. If we cut that down, we're going to degrade the frequency accuracy. Certainly trying to get an accurate Doppler frequency shift quality measurement from the 5 millisecond second tick is not going to work. The more interesting thing about that was maybe using the second tick as a way of discriminating just on the basis of time, which signal is which, because there is about a 17 millisecond delay at my location between the time of arrival from WWVH versus WWV. I wrote a little script that lets you put your Maidenhead grid square in, and it'll tell you what the time difference of arrival is just based on great circle calculations. Isn't going to indicate anything accurate about what Doppler or path length shifting it's going to do. So,
I think
and
we
then
can still do it,
been
Michael,
working.
but we can talk about this in the extended session.
Cool. Otherwise, working on some Whisper Demon documentation. Again, I just would urge anybody who looks at that documentation and finds gaps, flaws, potential ways to improve it and whatnot to let me know. If you want to see the documentation, it's in the docs directory. If you've checked out 3.3.1, for instance, it's definitely there. And you can do that just by looking at the GitHub site. You can pull down the version and without even checking it out. And there's I think, yeah, there should be a link in the README markdown file that's on the GitHub site too. And you can browse the documentation with a web browser from the clone you make on your local drive. Back to Nick.
Okay, well, I think I've called on everybody. So I hear no other people saying I missed them. So I guess we're open for general discussion.
Michael, I think you can still do it. You still do the FFT over the 45 seconds, but you just overwrite zeros over the periods where, you're being QRN by the other station or by the seconds ticks or what have you. It'll
Yeah.
reduce the noise ratio, but you'll still have the resolution.
I hope so. It'll be interesting just to check it out. Yeah. And it may be possible too, just by looking closely at the second ticks, which I've been trying to do in the meantime, to be more accurate about the onset, turning on a window and turning off a window for a particular station. So that'll end up being a little bit more accurate as well, at least at the beginning and the end of the duration of the tone.
Yeah, the frequency accuracy that you want is a function of the time span over which you look. It doesn't have to be a continuous
Right.
observation, but as long as the endpoints are still spread out in time. It's kind of like when you're trying to determine the orbit of a new comet, right? You don't have to make continuous observations, but you want those observations to be spread over a long period of time, even if they're not continuous.
Right. If there's variations that are on a sub-minute level, though, you might miss them, but
Well, if there are
it's going to be
variations of
inevitable
sub-minute
under these
level, then
circumstances.
you're not going to get 1/10 of a hertz accuracy anyway, right?
You need at least 10 seconds to get the
Right,
1/10 of a hertz
right.
accuracy. At
So,
least 10
right,
seconds. Yeah.
right. So is it going to be stable that long? Well,
Hopefully.
yeah.
Well, maybe not. Sometimes, Gwynn was pointing out those traces of things that just suddenly appeared at a high slope coming in. I think one of the things that's kind of interesting is that the path length doesn't determine the delta. It's only a few nanoseconds in variation, so that's not really worth looking at. You
Well,
can't get
there is a
resolution
path
quite that.
variation. I mean, that is what Doppler means, but it's not as much as the distance between Colorado and Hawaii, if that's what you mean.
Yeah, I was just thinking about the rate of. It's more of the rate of change in the path length that affects the change in the time of arrival.
And the
there's a
dollar.
big, yeah, yeah. Anyway, if we can, I'm going to try that. I'm going to try finding what I'll get the information that you sent and put blocks on it, fill it in with zeros rather, and then
Yeah.
see if that eliminates that intermod problem. That might end up being real fruitful.
Yeah, I
The
don't know how
other
you do
part,
it
though,
now.
is like to do a comparable signal to noise assessment. There's one problem I need to solve is to simply not record anything if the signal to noise level is below a certain level, because that just makes everything even murkier. But I need a
Well, it
signal. I
certainly
need an
means
accurate assessment.
it certainly
Go
means
ahead.
your result is not very reliable. Yeah, I mean, there's going to be a threshold effect there, just like there is in FM, because that is what you're demodulating. It's a form of FM. And when you get down below about 10 dB or so, it's going to become very uncertain.
Yeah.
Phil, I have a question about this distortion. Is it actually causing intermod in the transmitter?
Yes.
Or is it in the demodulation process that the sidebands are showing
Well,
up?
it's in the transmitter in a very special way. I mean,
right. The reason I ask is I wonder if we could correct for the distortion before demodulation.
I've been thinking about that too. You can certainly try to model the transmitter. I mean, it's repeatable. If you look at an
Right.
IQ plot, it's
Of course,
very repeatable.
You got to model the phase shift and then reverse it
Well, that's what I
somehow.
mean. You know what signal it's sending, therefore you can predict what the effect is going to be on the phase, and you could
Right.
take it
But if
out.
it was
Yeah.
actually mixing in the transmitter, then the those intermod products are already there. But
They're already there, but you can cancel them out if you're
yeah,
very careful.
right.
That's what I've been thinking about too.
But don't you have to have the timing right in order to make sure you're lined up? I mean,
Well, it's
the whole
kind of
in
the
some
similar
in some
to
respects these.
pre-distortion in a linear amp.
Right, right. Yeah, you do have that timing because you know the phase of the tone. I mean, you can see that from the amplitude. And you put this through an inverse, a model that undoes what the transmitter is doing. And you could, in principle, take out a lot of the extra sidebands created by the phase modulation. It's deterministic, right? It's not noise, it's deterministic. So, and we'll also remember we've got a local reference, right? We've got at least one receiver very
Simulation.
close to the WWV site to see exactly what it's sending with hardly
Oh,
any.
that's right. Yeah.
Yeah.
Yes.
And so we could characterize it very carefully, assuming it doesn't change, assuming nobody's working on the transmitter while we're doing this. We can get a very clean off-air reference right from almost from the transmit antenna.
And then Gwen sent out that a plaintive call for more people to work on data. Did you see his email? And he wanted the bandwidth widened too. One of the things that was evident from some of the pictures he sent were the variations that he was seeing in the spectrogram were exceeding the 4 hertz, plus or minus 4 hertz bandwidth of the spectrogram. So, if
We
we're
had
since
some-
we're
Yeah, we had some discussion about that with Gwen on an earlier telecon today, and then with Rob on a later telecon today as well. And yeah, we could see that the Doppler did exceed plus or minus 5 hertz at down in Antarctica. And I've also seen it. I have observations during the Gannon storm from May of 2024, where the receiver at my station also just went right off the scale. So I think there is a reason to do that. I suggested to Rob today. Rob, I think, is going to look into writing some code to automatically look at where the maximum excursion is and then set the bandwidth that's sent up to Bill's server for on a daily basis to a value that captures whatever that daily value is. So have some sort of like an adaptive method, because the Whisper Demon system right now does save, I think, like 8 kilohertz worth of bandwidth for 2 months. So it's very easy for Rob to go back, look at the past 24 hours, figure out what the maximum excursion is, and then make sure you send back an appropriate bandwidth.
Daniel, I got a physics question here. When it's that fast, does it mean the electrons are actually moving that fast, or is it the densities are changing? I'm not sure it matters in practice, but
Yeah, I'm not really sure, Phil.
I mean, I think of the ionosphere as moving up or down, but I think
Yeah.
somebody said something during the conference made me realize that's not necessarily what's happening.
Well, that is
It's not the
true.
electron speed that you're seeing, it's the change in virtual height.
Right.
Virtual height, yeah.
Yeah, but you're right. It's not just, it may be moving up and down. It may be that the electron density is changing. So like so you might have a change in index of refraction. There are a few, like 3 different mechanisms that can cause it. And so I know Shibaji Chakraborty, his model, the one that he's using, does look at the 3 different mechanisms. And so there is some work going on to try to disambiguate which ones we're seeing.
Does it actually matter? I mean, from an engineering standpoint, do you see a difference in what they do?
I think for I think for at least 2 of them, yeah, no, I don't think it does. I'm not entirely sure, but I think it is a little hard to disambiguate.
Well, is
So
there a
from
change? Is there a difference in how the group and phase velocities change over time?
Yeah, I'm not sure.
Okay, all right.
Well, actually, the short answer is yes.
Yeah.
Because
Well,
yeah, the density definitely changes the both the phase and group velocity. So the phase velocity changes that's causing the refraction.
all right. Now I don't feel so bad not understanding it.
I was wondering if we could change the topic a little bit. As I said, Tom Pisano presented a poster at the HamSCI workshop about the project we've been doing with the Lackawanna Blind Association, and we've had some discussions about how we might be able to continue doing this project. And one of the things that came up was in discussions, I think here and at the HamSCI workshop with Phil, was developing a new interface for HF radio for people who are blind and visually impaired. And we're interested in writing a proposal to potentially fund Tom to work on this over the next year after he's graduated. And we're in the process of putting that together. And we had some questions that we just wanted to flesh out and possibly get some input from the group on. So would it be okay if we ask some of these questions and have a discussion about that?
I think that's a good idea. Go
Great.
ahead.
Why don't I let Tom take the floor, because he's already thought about some questions, and then we can just have a discussion from there. So Tom, go ahead.
All right. Thanks again, guys, for letting us, giving us your input on this project. It means a lot. So, all right, I have a few questions. So, if anybody has any answers or opinions, please feel free to unmute and speak up. I value everyone's opinion. So, I guess the first thing is we're thinking about what radio we should consider for the project. So I wasn't sure if I should go with, an off-the-shelf like ICOM and like make the software kind of like a modular software for I guess to start out with all the different ICOMs and then move on to other radios as the project goes further on, or we should start out in the SDR domain and maybe even look at, setting up the project with KA9Q. But my only concern with doing it that way is the users won't be able to transmit to my knowledge on KA9Q, but I'm not 100% sure. If someone wants to talk about that, maybe give me some information on radios we should consider first.
Yeah, that's right. I've only looked at radio at receiving mainly because it's A, it's the more interesting problem, and B, it's almost all the work is receiving. So
I'm curious, are you looking at obviously sight is out of the picture, but or at least limited, but are we talking about both hearing and tactile? Some sort of
All right.
feeling?
Yeah, so I had a nice chat with Phil Karn, and he gave me some really good input at the HamSCI workshop, and we were talking about kind of using a lot of voice commands. So kind of like you use your Siri or your Alexa. So you'll say, "All right, let's listen to 80 meters, 3.501 megahertz or something like that," and then the radio will go to that. Or, all right, now let's go to 40 meters, 7.2 megahertz. And then you would use a lot of voice commands to control the radio mostly.
yeah, don't stop
Yeah.
there though. I mean, that's just a start. I mean, you
Yeah.
you can be pretty radical here. I mean, don't, I mean, that's one reason I would, start with the SDR approach, it's my personal take, because you're not really limited to the kinds of interfaces that we hams are used to dealing with, the ICOM, Yaesu, whatever radios. Sometimes I think you have to unlearn all that stuff and think about what problem you're really trying to solve, and then, come in with a totally different way of solving it. As I told a couple of you guys several times, the best user interface is the one that doesn't have to exist in the first place because it already does what you want it to do.
Mm.
And part of my reason for doing it is not just to solve the problem for blind people, or who can't see the user interfaces we see, but I mean, I think the insights they could come up with are actually probably beneficial to everybody, not
Yes.
just people who can't see.
I
Would
had
there
a
be
good, oh, go ahead.
would there be some value? So there's some like universal, I guess, APIs, like there's HamLib. So I think HamLib tries to be an API that can interface with all radios by having one API. Would it be useful to develop the interface on top of something like that? And so that, like, would that be compatible with KA9Q radio and with like an IC 7300 or or would it be better to just focus on just like KA9Q radio?
Well, I'm a little biased, and I think you should do the latter. But I also I mean, Hamlet basically is an abstraction library, as I understand.
Right.
I haven't used it heavily, but I mean, it basically tries to make all the radios look the same by getting at the underlying function that you're trying to do, and all the different ways different radios do it. Um, I think I can give you that more directly, but if there's something you need, I can also add it.
Mm.
You know,
Okay.
it's always software, right? As remember Tom Park used to say so many times.
I kind of agree with Phil that it's probably easier to come up with the building blocks here. And because I would assume for a commercial rig, you'd have to build some add-on hardware that you would then run software in. And you might be better off in this environment that there are less moving parts. Well, I don't know
Yeah,
if
it may
that's
still
true,
be
but
worth doing because those radios
yes.
are out there and there's so many of them, and you can buy them, and they generally just work. But don't forget about what you're really trying to do, not just the syntax of the commands, but what underlying operation you're trying to do.
Right. And certainly if you are working, with something like K9Q radio, you would have access to like all the IQ data, all that additional information that just would not come across a CAT interface on an IC 7300.
Right.
Yeah, but I mean, think also about the higher levels of functions you want to do. Like, for example, okay, radio, tell me all the bands on which you are hearing FT8 right now. Or if I want to work Japan, what's the best band to do it on right now? Those are functions I can't ask a radio directly, but I can certainly ask a larger block of software that might include a radio.
So,
So
I'm
because
yeah,
you will,
curious.
my point is don't aim too low here. Aim high.
you have a database of what the radio has been listening to, particularly in K9Q radio. And, you know, you could develop commands that query that database.
Absolutely. Yeah. Yeah. Don't aim too. The main risk in a problem like this is aiming too low
Mm,
and not thinking about what you'd really like to do if you really could do anything. You know, aim
Mhm.
high. You can always lower it later.
right.
And I think the problem is uh, using tool sets that are common to everybody and not worrying about um, eye or visual components of the feedback, because some of that's already there. But um, in helping uh, blind people, you might be helping everybody.
That's exactly my point. Yeah, I was making that repeatedly at the conference when, well, it was funny. I was sitting on one side of the room, and Nathaniel and I could tell you were sending a steady stream of students over my direction. So I was telling each
I
one of
might
them
have
the
been
same
one of
thing.
Why?
them.
Why would
Yeah,
I
you
be
were one of
doing
them, I
that?
think. Yeah,
Yeah.
yeah. But I mean, we can already do things now that even hand with perfect senses can't do, like watch all bands simultaneously, and like I said, this is not limited to just people who can't see. I mean, this is something to benefit everybody.
Yeah.
The To what extent have you already identified the existing aids in computer interfaces for blind people? I mean, those are probably pretty mature at this point,
Well, we
right? For
haven't, but I mean, they're the best ones to tell us because I don't know what their problems are. I don't know what tools they have. I haven't known any blind hams well for a while. I used to know some, but I don't know what tools they have now. They're the best ones to ask. Only
Right.
they can tell us what they need. But at the same time, I'm hoping we come up with some common insights that will apply to deaf hams or to hams who have perfectly good vision and hearing, but still want to do things that they can't do by themselves.
Well,
Well,
we're
that's
we're
why I'm
talking.
asking whether
Yeah.
there's not some really relatively mature human-computer interfaces for people with disabilities. And as a higher level of abstraction above any particular application. I mean, the application might be interfacing with a radio, but it might be interfacing with a word processor or a web
Yeah.
browser or whatever.
Well, the
And
problem
if
is,
those,
Michael, there were, but then GUI screwed everything up. And it's
But
the
I know
biggest obstacle they have, right?
Yeah.
there are very
But
mature things that they use with like iPhones and screen
yes.
readers. Like I mean, these people are quite facile
right,
Oh,
and that's
yeah.
why
with
I'm
their
Oh, yeah.
thinking that
systems.
if you have the computer interfaces with some level of maturity that already exist, then it's a
Yeah.
question of tying the radio function to
Right.
those extant computer interfaces
Yeah.
in whatever manner they're in that way too. You're going to leverage tools that people may already be very familiar with and know how to use already, rather than trying to reinvent a new Siri or a new Alexa or a new
Right.
whatever. Um,
Mm-hmm.
Other haptic interfaces. If that stuff is all there, then it's a question of linking it in. And then the many things that Radio D can do that a regular radio can't are things that still require some development in terms of putting them at the fingertips, even of people with eyes and ears and hands,
Right.
that as you've already said. So, but if those tools already exist, that you sure would like to use them because that's what people are used to using already anyway. So,
Yeah.
Well, one example I want to mention, and you probably have talked about this, but Phil wrote the WWV simulators, and I was amazed at some of the use of voice libraries in that work. I think it was really quite amazing.
Well, I
And
had to
that
go
was
find one.
Yeah, you use sort of an off the shelf, and they vary, right? From
Yeah.
Yeah,
between
there was one for
Linux
Linux,
and Mac
and
and
the
Yeah.
Mac
Windows. They're
one
all
worked
different.
a lot better than the Linux one did, but
Yeah.
And then when I talked about this quite a while ago at a Guru Radio forum, some wise ass Canadian in the back asked me about CHU. So I went home and did a CHU emulator. Then the hard part was finding a male French Canadian voice synthesizer.
Yeah, the
So I
ones
took
that
that
say
as a
A at the
challenge, you know.
everything, right?
Right.
It's a solar flare, eh?
Yeah.
I can mention a couple of things about this. I had a local person reach out to me that's blind. Became interested in ham radio and asked me if, or I was asked to go and visit with them and try to help them get started in ham radio essentially. And so I was faced with what do you do or how do you deal with this? And I did a little bit of looking around the ARRL, and they do have some papers and information about how to deal with blindness and amateur radio. I got those and read over them at the time. The person I was supposed to work with, though, was having some emotional problems about the whole thing, and it never did materialize. But, I tried 2 or 3 times to thinking that it would help him to get involved in ham radio and couldn't make that happen. But anyway, the other issue that I know about is my own issue that I'm faced with, and that's type 2 diabetes. And that can lead to macular degeneration, which can eventually turn into loss of your sight, at least partially, if not completely. And recently I've had some issues with my retina and started to see light flashing. So I can see where it could be a real possibility. Even if you're maintaining your A1C and doing everything you can to keep it from happening, if it's genetically in your background, it can come on you. And I think
Yeah.
in today's world where a lot of youngsters are not eating properly and overweight, as talked about in the news, that the possibility of issues like that are going to grow in time. So I think this is a very real
Yeah.
topic to stay on top of.
Well, Bob, then you're as good a guy as anybody to come up with some creative ideas here.
Yeah.
Yeah, I know
Well,
that.
there's some creative guys out there. I found one a couple years ago. He got really excited about my WWV emulator, and he even told me about a bug that he heard in the time code generator that he could hear by ear because he was decoding it by ear. And he found a bug that showed up only during, I think it was the day before a leap second or something weird like that. He's still, oh, I got to contact him again.
that's great.
All right. Well, do you want to go into Daniel or should I talk?
No, I was gonna say we are planning on talking with some of the people from Handy Hams tomorrow night and finding out what they know already. We are planning on also working with we have a professor who's an occupational therapist here at the university who specializes in low vision. We're meeting with her tomorrow to get some more ideas. And we'll certainly be able to talk more with the people at the Blind Association.
Yeah, one request I have, if you're going to do this, is
Yeah.
tell them don't to hold back just because they think something isn't feasible.
Okay.
Tell them that ask anything they want. We may tell them that we tried and we don't think we can do it, but don't tell them to hold back because they think something is not doable. It might be doable.
Okay.
We just haven't thought of it yet. Don't tell them that they'll feel stupid by coming up with a request that turns out to be infeasible because we'll never know. Okay?
Yeah.
All right. I'm not sure how much we're going to be able to get figured out in the next week, but we'll do our best.
You never know.
Well,
You never
we'll
know.
have more time to talk about it.
Yes. Tom, did you have other questions?
Well, first I'll make a comment and then I'll see. And I'll maybe go through a couple, one or two more questions. Well, my first comment is, again, I really appreciate the input. I guess there is a clear need as we can see with health problems and everything going on in the world. So there's a clear need for the project. I really like that idea of it helping hams out, with things that they might not know, like when is the best time to talk to Japan, or what band do I need to go on right now to do that, or I want to talk to Greece right now, and then it puts me on whatever band, and maybe the best frequencies, or if someone is already transmitting, we could receive them. So I really do like that. It could be a good way to learn as a ham, or just overall get better with your skills. So I like that point a lot. um so those are some really good takeaways I got from that. So thank you. I guess I was gonna ask, this is a general question, and this is kind of answered a little bit in the previous one. If anybody has worked on similar projects, and if maybe they have people that we should consider reaching out to as well, that might be very beneficial to talk to about this.
Um, so one guy to talk to is Dave Marthouse. I have not heard back from him in a while. Even though
Oh,
I've sent him a
Dave,
few.
I knew him when I was in New Jersey. I haven't heard of him in a long time.
Really?
He's still around?
Yeah. Well, I was talking to him last year, and he came over Zoom to the first meeting I had with the Lackawanna Blind Association. I invited him to the HamSCI workshop at NJT, but I didn't hear back from him. So I do have his phone number though, Tom, and so you could try giving him a call, or I can try giving him a call, and we can try to get back in touch with him. But I did just try emailing him like, a week or so ago, saying like, we're having the HamSCI workshop right in New Jersey. Do you want to come? So yeah, hopefully, hopefully he's still
I'm
around there.
glad to hear he's still around. I lost touch with him when I moved to California, but I knew him in New Jersey, and he
Yeah,
seemed like a very clever guy. He's always thinking about stuff, so he'd be an
yeah, Ed F. Check connected me with him when I was starting this whole thing, and said to talk to him. So yeah, Tom, I'll give you his phone number and his email, and then you can try giving me a call tomorrow. The other thing that you said, Phil, the other day that I thought was kind of interesting was um different ways of maybe hearing the waterfall display. You know, now that we have radios with waterfall displays, it really kind of changes how we look at and think about spectrum. And you were saying, well, maybe for someone who's sight impaired, you might be able to compress the waterfall display into an audio stream that we could hear. Do you want to talk a little bit more about those
Yeah,
ideas?
this is an idea I kind of just talked with for a while with that guy I was mentioning in Ohio, who was my big fan of WWV Sim. And I just kind of mentioned this idea. We never really took it anywhere. He thought it might be doable. But the idea was to take a Fourier transform of, a block of spectrum, just like you do now, but then turn it, compress it, drop every other bin, or, take every 10th bin or whatever, and then turn that back into a time domain signal. I don't know what that would sound like, but, blind people find ways of making amazing use of their hearing, of their remaining senses. And they can adapt to things like this that you never would think would be practical, and they can make amazing use of. We didn't follow that one, but I would like to find somebody who might be interested in pursuing that.
So I have a dumb question, maybe.
Yeah,
If you had a carrier that was center, consider it mono, and if there's a carrier to the left, it would be in the left ear and blah, blah, blah. So I'm
yeah,
just
yeah.
curious if you could split the screen such that those tones are spread from center frequency out.
Oh, yeah. I mean, in fact, I've already done that with my monitor program. If you have a whole bunch of channels to listen to, you can place them across the stereo field. That idea is not really original with me. I think airplane audio panels already do this, since you often have to listen to multiple radios, and you want, ideally the radio should seem to come from the direction in the panel where it's actually mounted. That would be a logical thing to do. But yeah, there are all sorts of tricks like that. But we have the disadvantage that, because we can see, we don't have an incentive to actually try these things out. Many blind hams do. and they would be perfect ones to tell us whether this is even a viable idea or not. It's easier for us to come up with ideas. They have to tell them if they're practical.
Mm-hmm.
And even for sighted people, combining this with the pan adapter may make it where you observe things that you might have missed.
Yeah.
You could do something like pick the middle of the spectrum as middle C, and then make tones for the different signals that are over some level that are there, and play the music that you get out of it. You might have a hit song
Well, that's
playing notes of the birds that are sitting on a wire. That was a song.
I was actually a couple years ago thinking of a joke April 1st article for QST where the FCC has just mandated that all new digital modes have to use harmonically related tones to be, aesthetically pleasing to the ear or something like that. um, I've stopped writing articles like that because too many people would believe them. Back in the 80s, I wrote a few April Fool articles and people got angry when they found out they were a joke. So I don't write them anymore, but
So it happens when you write them too well.
exactly.
Yes.
Exactly. Or not even all that well. It's amazing what people believe. But I mean, don't forget things like skimmers. I mean, we already know how to do that with all the digital modes because they're designed to be decoded by a computer. But we're getting to the point where AI can probably do a pretty good job pulling call signs out of CW and SSB signals.
Yeah.
And obviously, that would be a help to every ham, not just those who were blind.
Mm-hmm.
AI is one of those fields where I have to admit that I was wrong and kind of ignoring it for so long. Through most of my career, AI was seen as like, a joke. It was where people went where they really didn't do anything real with computers. And then all of a sudden they came roaring out into reality. And suddenly it seemed like there's all sorts of applications. And this is certainly one of them.
Those Bayesians came along.
Yeah, the Bayesians came along.
Yes.
Sounds like a Star Trek culture, doesn't it? The Bayesians. So yeah, I mean, a lot of these could have general applicability, not just to people who can't see or can't hear. And we think about it, I mean, hams who are deaf even have a bigger, disadvantage when working radios, since so much of what we do is auditory. You got to find a couple of them are both motivated and clever and resourceful, and then just sit there and listen to what they say. And yeah, make sure they don't feel stupid for coming up with ideas that turn out not to be practical, because you'll never know until you at least kick it around a little bit and maybe try it.
Sounds good. Thank you.
I
Sounds
mean,
really good.
this would be a wonderful engineering, undergraduate engineering project, I would think.
And it can help people outside of radio.
Yeah.
Mm-hmm. That sounds really good. It's 10 o'clock over here, so I might be ready to get a little sleep. But do you have any other questions, Tom, before we go?
I think they really hit most of them, and I was gonna ask about if we should consider any physical hardware, but it seems like right now we should probably just focus on software and get a lot of feedback from the community, mostly blind hams, and just try to make the software as best as we can. That seems like the best direction right now. If anyone is opposed to that or has a different viewpoint, I'd love to hear it.
Oh, I agree with that, but I'm a software person. The great thing about software is it costs nothing to reproduce once you've got it.
That was one thing I said about this project, that if you do it just within a year, you could immediately distribute it to many different people.
Yeah, and then
But
it'll hopefully have a life of its own even after you stop working on it.
Mm-hmm. But one of the nice things we can also do, Tom, is just I'm Dr. Spletta is going to come to our 11:30 meeting tomorrow too.
Okay.
there's some possibility that, you know, this might also be able to be folded into like a senior design project, or like a student project too, that it might not be the main portion of the project, but maybe it could inspire some senior capstone projects that could kind of like add on to the main thoughts.
I see we have Rob Robinette now.
I'm gonna say 73 for the night, so I can get a little sleep. But I did get a chance to talk with Rob earlier, so
Okay.
thank you everyone for your discussions.
Right, Nathaniel, thanks for the conference. It was fun.
Oh, you're welcome, Phil. Thank you for coming, and thank you everyone for coming.
I always like going to something a ham gathering where I'm not the youngest one in the room.
It's good. It's good. Thank you.
Yeah, thanks everybody. I appreciate it a lot, and hopefully we'll get you some updates in the future.
Do you want me to leave the recording on, Dave, or do you want me to turn it off?
Yeah, why don't you leave it on?
Okay, great. I'll make you the host, and then
Okay.
you can be in charge of everything.
Okay.
Have a good night, everybody.
Good night.
Okay.
Good night. Michael, if you have some time, would you like to have some discussion about the VLF stuff you were interested in?
Sure. What's your schedule like tomorrow? I'm gonna probably hit the hay here pretty soon. So,
Well,
but
I am working. I get out of work usually around 4:30 or 5.
5 o'clock your time would be 6 o'clock here. I have a meeting that ends around 5, or rather 6 o'clock here. So, how about like 6 p.m. your time, or 1900 my time?
Okay. Yeah. We could do that.
Cool. I'll you have my phone number? I think I sent it to you in an email.
Yeah.
If not, I'll send it to you again. Great. Give me a call then. I'll look forward to it.
Yeah. Yeah. Uh. Uh. What were the main things that you wanted to talk about, and just so I could kind of get an idea.
Well, it was the assembly of the preamp and the I guess looking forward to what's going to be necessary for the B plus and B minus antennas. And if I should go ahead and start assembling a Manhattan board, or wait for the KiCad version and order it from JCL BC or whatever the heck it's called. Yeah, just some practical nuts and bolts like that, I think.
Okay. I'm just starting to figure out the process for routing traces in KiCad. It doesn't seem to be as intuitive as Express PCB. I just tried it earlier, and for whatever reason, they're not neatly connecting to the um, vias that are there, and I don't know why. So I'll have to figure that out. I don't really know what the timeline is when I'll have it built and working, because I mean, once I figure out the you know how to how how to route the traces, then I have to make sure that the board works. I do have to test it. I don't know what the time I don't really know what the timeline is going to be. But it all depends on how confident you are in um, um, building it. If you feel it might be too complicated, or it might not work, or it might not be a fruitful use of time, then yeah, we'll just wait, and I'll I could have you build it from the layout if you want, but if you aren't too intimidated, or if you feel that you could do it, you could definitely start building it. The
Right.
only trouble is that, like, since you're going to be building it in a pipe, um, you have to have a way to cut the FR4 material, and that's not always an easy thing, because you have to have something like a shear cutter that could cut large pieces of FR4 material, and you might not have access to one, or might not have that. So even if you do build it on a piece of copper clad board, then you might not have a way to cut it.
Oh, I can figure something out. I'm not intimidated by doing it. I have every expectation of failing. So
Well,
that's just occasion to learn, though, so I can do it again. So that it's a that the fun of it for me is learning how to do stuff. So, and I've got some friends here, Dave Witten lives here. He's got lots of gear. I've got a woodworking shop. Dave Larson lives near me too. We can figure some stuff out in terms of
okay.
some of the
I mean,
mechanics. So
yeah, we could discuss the details
yeah,
further
we could
tomorrow, but
discuss that tomorrow.
yeah, but I mean, if you feel that it would be a good thing to do, and I think it would, me personally, I would build everything Manhattan. Um, but since I'm going to be I want to reproduce a lot of these things. It's much easier to lay on a board. Um, but yeah, it's totally up to you, uh, and we could just talk about it tomorrow. But
Yeah,
yeah, I might end up calling you from a different number. But but
no
otherwise,
worries.
um, yeah,
I think
yeah,
Elmer was interested in doing something along these lines too, and he's got a lot of expertise. Look at that! Look at that shop he's sitting in. He's got all sorts of crap over there, and he can cut the crap. So
Yeah,
that would
well, I was
be
just going to say I can cut the shape of the Manhattan project really quick, because I started laying mine out in KiCad as well. It was just the bill of materials I was still working on.
yeah.
oh,
Anyway,
nice.
we can flesh some of the details of that out tomorrow. And in fact, we could get on Zoom or something like that, the three of us, if Elmer was available, and come up with a plan.
Okay, definitely.
I'm going to sign off now, though, guys. I'm getting ready to go to bed. 73, everybody.
Definitely.
Have a good night.
So, Phil, you're still around?
I guess I am. I was just talking to Kimberly, still unpacking from my trip last night. And I know I must be having a allergic reaction. At least I hope that's all it is. I always
I
feel
hope
crappy
so.
when I come back from a trip. I'm just wiped out.
Moving is even worse, as you know. So I'm still,
Yeah, I see your boxes in the background there.
and you can hear my hoarse throat is in.
Yeah, I heard it when we were talking the other night too.
Yeah, so it's Anyway, I just wanted to give you a report. Others can hear it. I did a check-in this morning on Whisper Demon, and I think I've had a second pretty reproducible case where um, if you do not reserve Radio D and FFT, the PROC and FFT, and give them their own cores, there is there must be sample loss someplace in the chain.
Yeah,
And
I
because
believe you.
the right times drift.
Yeah,
And I just don't see any error, as I've told you before, there's no packet loss, no RTP, sequence number errors. Um, so it appears, given my understanding of the data flow, that it's someplace in PROC and Radio D that they get starved of CPU cycles and somehow fall behind or drop something.
well,
And
this is making me wonder even more where the interrupt handler is being serviced
well, I don't know.
on the
And
same core. Maybe that's the problem.
yeah, well, what I'd notice is when there's of course, this happens when Whisper Daemon fires up all the Whisper D decoders. So CPU
Right.
usage would go to 100% on all the cores by reserving uh, restricting the two threads and excluding others from the pair of hyperthreaded cores seems to address the issue. It does seem to be some kind of a cache contention, and it looks like it must be at a level 3 cache because uh, the level 1 and 2 caches of that pair of cores are not shared with other cores. Um, I'm
Sorry.
sorry.
Yeah, Kimberly just said something at the mic.
Oh, um, the so and you can see now with them segregated that when the other cores fire up, running at 100% on all of the non proc and FFT and Lin cores, that the FFT usage goes from about 45% of that core it's on to about 60%. So I assume that 15% increase in CPU utilization is really due to cache stalling. That while the cache
Yeah.
is getting refreshed. And that cache stalling
Cache
must be
or maybe, an interrupt service routine.
if they, I don't know if,
Don't jump to conclusions here.
yeah, no, that's why I'm bringing it up. You have, I mean, there are plenty of other, the kernel, yeah, I didn't modify grub, and that's an experiment we could do to exclude all of the kernel processes and threads from those cores. I mean, that might be an experiment that would determine if it was kernel uh, usage. Maybe reserve one core for the kernel, one core for the for your stuff, and the rest of the cores for Whisper Daemon. I mean, that might be an experiment. I am really pleased that it seems like if with the changes I checked in today, that dedicating on this particular CPU, dedicating core 0 and 1, a hyper-threaded pair, to your stuff, um, and restricting Whisper Daemon to the other cores, so excluding it from the Radio D cores, seems to address the the uh, sample loss issue. So, um, I don't know, Scott, you mentioned at one point perhaps instrumenting Radio D in more subtle ways, because there's no indication of a problem. which is, I think the only thing that would be good if we could gain from this process would be to learn if we could, um, monitor this and detect this condition if it were to occur. I'm not very satisfied with a solution that just involves this recipe works, we think. I mean, I don't. I don't know how large the US, I guess the USB transfers are pretty large, but it doesn't seem like it's losing a lot of samples. It seems very few.
Yeah.
I mean, it takes a
I'm,
lot.
I'm listening. Sorry, I'm still unpacking stuff, but I'm listening.
Okay.
Yeah, I don't want to just do something that is black magic.
Yeah, I don't like this solution, but it is a solution, and it's enough that I feel I can go forward and focus on some other issues. Um, so anyway, it's a to do whenever if and when you feel like you want to look at it. But I'm pretty happy with what I
Right. So
have
at
right
some
now.
point, we just have to say, okay, we don't have enough CPU. We need another computer. I know you like to avoid that because of the
Well,
multiplier factor times all the stations. I
yeah.
know.
Well, I mean, if we were to find, I mean, I suspect that if we were to do what I described and modified grub and so on, that we could make it reliable. But without error logging, telling you that it is none of these errors are occurring, no solution, even moving things to another physical computer. We have no notion that we really solved the problem.
Yeah, we certainly would like to understand the problem, even if it's
Yeah.
not solvable. You got to understand it.
Yeah. Anyway, I mean, I don't I don't mean this to sound like bad news. It's really quite good news that there is a way to, you know.
Well, I think we probably, and I hate to do this, but probably it's time to go digging into how the USB driver works, how the samples, how the handled, how much copying of the data there is.
Mm-hmm.
There's probably more that we would like between the device and the buffer in my program. There's already enough inside because I have to convert from integer to floating point.
Do you copy these samples from the kernel memory space into user space?
I actually don't know that because remember I got these drivers from Franco.
Yeah.
And they kind of just worked. I know what he does do is he allocates a bunch of buffers and he hands them off to the USB subsystem, and then they come back full, and then you empty them, you hand them off again, which implies that maybe it is trying to do zero copy IO. But I have to do at least one copy, and I'm converting from integer to floating point.
Yeah.
I've even thought about looking for FFTs that are integer FFTs. It's a way of, I don't know if that could be any faster.
And is there does the output of the FFT process, does that double the size of the data set or?
Well, of course it does. I mean, it goes from 16 to 32 bits.
Well, that I'm talking about if you start from 32-bit float to linear sample to FFT of that block, that's a transform that consumes no memory.
Well, an FFT, it's a one-to-one, right?
Yeah,
So it
yeah.
doesn't enlarge or contract the data. However, my conversion from 16-bit linear to 32-bit float does double the size of it.
Yeah.
Of course it does. Yeah.
Yeah, of course. Yeah. Well,
plus the FFT is working on twice as much data, which is why I've thought about possibly working. But all the FST, the big ones like FFTW, only work on floating point.
Yeah. Well, I mean,
there's a version now that works on half precision floats. I wonder.
Well,
remember, I've been trying to get you to.
I know you've been trying for a long time. I don't object to it at all, Phil. It's just that I'm not sure that, the end result has to be a data set that's in
Well,
the
earlier on in the
server.
meeting, I think before you came, they were talking about needing wider bandwidth on WWV because there were artifacts more than 4 or 5 hertz away from the nominal frequency.
Yeah, so I talked with
You keep saying that memory storage is cheap, so hey.
well, what I suggested that meeting this earlier today was that it would be possible. I don't think that hard for Wizard even to take a look at um, at the 16 kilobit recordings and look if SOX or some other utility would report the maximum frequency deviation over the 24 hours, then I could say, okay, this is a site that needs, plus or minus 10 hertz, not plus or minus 5, and tell SOX to down
All this is
convert.
just a form of data compression, right? The whole idea of data compression is looking at the data and seeing how much useful information is in it, right? And
Yeah,
then keeping
yeah,
that useful information. That's what data compression is, right?
yeah. Well,
Just blindly saving
yeah.
everything.
Well, SOX may have a command that it does, I do the same thing. Well, I was doing the same thing with SOX, where I'd have SOX look at the 16-bit samples and say, what's the peak value? That's a peak amplitude.
Yeah.
Well, that's pretty
Yeah.
straightforward. Uh, have asking SOX to tell me what is the what is the peak frequency and what is the peak deviation of the frequency in this recording. I don't know if I can ask it to do that.
Well, it gets complicated because, like I said, this is fundamentally an FM demodulation process, and like all FM, it's going to have a threshold effect.
Yeah.
And so, a little more thought's going to have to go into it to just that.
Well, as I hope I expressed, I don't know if it's what technique would be appropriate, if any, to detect the maximum frequency deviation over the 24-hour recording. But if there were a way to reasonably establish that, that there was a deviation greater than 5 hertz, then I could tell SOX that, to down convert to 20 hertz wide output file instead of the 10 hertz wide output file that I tell it to do now. It's just that I don't think we want to have every site uploading, a data that's twice as large. There's unnecessarily.
Yeah.
But for the Antarctic project, Antarctic projects, the Doppler shifts are large enough that we're losing data if we just use that. Now, maybe we just say, hey, you're an art, you can, this is
Well, it
a
doesn't sound like
variable.
much to start with. Come on, with 15, 20 hertz. I mean, how much is that really?
Well, it's 25 megabytes per day at 10 hertz.
Yeah. And what kind of connections do they have to the outside world?
Oh, I don't think that's a problem. There's Starlink connections.
Then it's
That
not a
is an
problem,
issue.
then, is it?
Yeah, so it may just be the solution may be to say, have Whisper Daemon here. Here's here's the default is 5 hertz files, and put in the config file, 10 hertz file.
You know what the biggest problem in engineering is, Rob, that I've discovered in my career? Solving problems that don't exist.
Yeah.
Come on, you know that. You're an engineer. I mean, how many times have we solved problems that turn out not to be problems, and how much time do we spend on them?
Yeah. Well, that's why it's a useful discussion right now. I'm thinking the easiest thing to do, just make it configurable. I mean, there's only going to be 4 or 5 sites that'll be uploading 50 megabyte per day.
Right.
That's not a big, out of the 150 sites, they're going to have 5 sites that are, double data size. I don't think that's a big burden.
No.
And investing a lot of time in figuring out an algorithm to dynamically change the down convert seems like a lot of work for very little benefit. Okay, I've come to that's my decision. I'll make it configurable.
Anybody else wants to talk? I got stuff I'm doing here.
Nobody in the Antarctic group here, I think, is. I'll mention that, to that group, but that's an easy solution. And the only issue is, can Bill Engleby's PSWS spectrographs, they hopefully will adjust for dynamic range of amplitude. Hopefully the spectrographs would adjust for the dynamic frequency range instead of plus and minus 5 hertz plus and, the wave file header tells you the bandwidth. So the information is there in the wave file. Anyway, okay, I think we've taken enough on that one.
Yeah. I don't have anything more else.
Okay. Anyway, I can imagine you're tired.
I am. Yeah.
Okay. Thanks for being a sounding board.
Sure.
It is really amazing to see this thing at work. I mean, your code processing 250 megabytes per second on half of a core.
Yeah. Well, it's really FFTW is doing that processing.
Well, that's
yeah.
You're the
By
one.
the way, Elmer, while you're still there, thanks for the great the time we had at the bar. I almost didn't come down there because I was so tired, but war stories about HBO was a lot of fun.
Yeah, that was a good times.
Yeah.
Did Elmer tell you how we first met?
No. He did tell me about Captain Midnight, but that, no.
No, one of my startup companies made real-time video encoders. I think the one we sold to HBO, MPEG-4.
Okay.
And HBO bought 100 and some of them, and I was the person who went to install them in Long Island, and Elmer was in charge of the facility. So it was that was in 2006 or something like that.
Oh, that was long after Captain Midnight.
Oh,
Yeah. But you had the only viable working system.
It was I lost a lot of nights getting that system working.
You have no idea what I went through on my side.
Anyway, so we were reintroduced at I think almost the last NAB convention, and our mutual friend whose name escapes me, I said, "Do you know Elmer's a ham?" And at this point, I was, I think, a little involved, so that we started up that discussion. So,
yeah.
And then Bear ensued.
Yeah. Yeah.
Oh, and Clint, if you're still listening, I saw and tried to answer your messages about signal level calibration. I'm not sure I've got it right, but I have tried anyway to try to keep signal level calibration through KNIQ radio. And if I missed something, or you or Scott or whoever finds I missed something, please let me know. I'll try to fix it.
So as I understand it, Phil, that basically 1 volt RMS on the SMA connector, or
0 dBm.
0 dBm on the SMA connector corresponds with about a floating point value of 1 for the peak of the sample.
A floating point power of 1 for a complex signal. Yes.
Yeah.
That's my intent anyway.
Okay. So
when all the front end gains are 0. Yeah.
Yeah. Okay. Well, I think that's the information that Bill Angleby.
I made so many errors of factors of 3 dB or 6 dB in various places, and I'm still not sure I've gotten them all, but I'm trying.
Okay. Well,
so to your knowledge, no matter what the gain is of whatever hardware you're using, it should scale to that on at least on.
Well, right now, the only attempt I've made for an absolute calibration is with the RS-888 because especially the ones with the tuners have highly variable gains that depend on frequency, and they need to be calibrated. But yeah, for the RS-888, that's my intent, is that 0 dBm on the antenna is 0 dBFS at the output when all the gains are 0 throughout. Yeah.
So 0 dBFS. Let's say, hang on. Well, I realized after sending the first version of the email that dBFS should never be in there anywhere.
Well, 0 dBs is relevant to the input and the output, but not the middle.
Well, I mean,
Wherever I'm using 16-bit linear, then yes,
well,
it does
right,
that.
right, right. But if we're using a floating point on the output, zero
Oh, that's
dB.
correct. That's correct. Yeah.
So 0 dBFS is what? 1 volt, a value of 1.0 RMS in the floating point, or does
Well,
or does it?
0 dB, drop the FS. The 0 dB in floating point
Yeah.
is 1 unit of power. Yes, a complex. That is the I squared plus Q squared.
Oh, okay,
Yeah,
okay,
that's my inside is always complex. It's only real on the input and or the output.
okay. That makes perfect sense then. And okay, because okay,
And that's where I was always getting confused is in my conversion real and complex.
right. But in this, but okay. How would that correlate then? Like, well, I guess that would correlate with what value in that would correlate with the. I mean, if you had a real receiver, that would correlate a fixed. So you'd have to run the numbers. What did that correlate to if you had a real receiver, not a complex?
Well, the arc striploid is real.
No. But your receivers may not be. So I was thinking at the far end of everything, like what is being spat out into, say, the 30.
At the output in the real in the complex float format.
Well, let's see. There's two cases here. There's the say Rob's file that he's recording 32-bit floating point complex. So
Right.
I can see that the sum of this the square root of the sum of the squares would be 1, ideally, right?
Yeah, or sum of the squares to be 1. Yep.
Well, yeah, whatever. Okay, yeah.
Same. Yeah.
Well, yeah, I guess it'd come out the same.
One's power, one's amplitude. Yeah.
Right. But if you had a real receiver instead of a complex receiver, that would correlate with.
It should be this. Okay.
I mean, then you'd have to go with something more RMSy or peak voltage, assuming only a pure sine wave and no other energy, right?
Yeah. I mean, I think I explained. I set up the convention I did on the input 0 dBFS because its primary use is in avoiding overload. Right. That was my reasoning for making a 0 dBFS real signal have half the power of a 0 dBFS complex signal, right? Because there are half as many numbers in each sample, right?
Right.
A real input has only one sample. A complex sample has two subsamples in it. And so I had a 3 dB factor in there. And in fact, I apply that 3 dB factor when I display amplitudes.
Okay.
If you find something that doesn't make sense, just let me know. But my intent,
right, yeah.
the intent is that it come out as unity amplitude power will be 0 dB.
Okay, yeah. The only hardware I have available to test with, I have a number of ways to get calibrated signal levels here.
Yeah, and I don't actually. So if
Right.
you find something, let me know.
Excuse me. And only hardware I have access to is the RTL, which is probably flat-ish. I think they're.
No, they've all got these preamps on the front that seems to have highly frequency dependent gain.
Well, the RA20 is on the RTL, and I did notice that there's a bug, that is mostly correct. That seems to be fairly consistent because
Really?
the Raphael chip seems to be pretty consistent within a dB or so from unit to unit.
Including the thing they call an LNA.
Well, the typical RTL SDRs don't have an LNA on the converter side.
Oh, okay. See, they call these things. I have no idea what they actually are. I mean, I just know what they call them in software, and I don't even know where they are.
Right. So on the RTL SDR, most of them simply use the Realtek. I mean the Raphael chip.
Right.
Has the LNA in it. And those are pretty consistent. As consistent as silicon is. It's pretty decent.
Yeah, there's a VGA which operates on the output, and that is consistent, which I would expect because it's operating at baseband. That I would
Right. Now, where that doesn't apply is that the RTL SDR, the ones that you buy, the V3 and V4, they actually have a single-ended transistor preamp for the direct input, which is what you'd use on HF, and that gain varies, you know, a bit.
Yeah, of course. Yeah.
Right. And then the other one I have access to is the RSP, which I found at least the relative gain, if you trust what the API does, seems to be right, but I don't know what the absolute gains are.
Okay.
Because I hitherto there's no way to know what the absolute gain is unless you write a utility program and do visual inspection of what's coming out of it. You know, they kind of abstract that pretty well.
Yeah.
So I have
two SDR play units. I have one of the original ones, and then I have one with two inputs plus a balanced input. I'm not even sure what model that is.
That was either the RSP2 or the RSP. I have the blown up one from Maui here. That was the so probably, let's see, I don't know if I didn't turn on my camera yet. Yeah. But anyway, yeah, there's a metal case one. There was the old RS2 Pro that had it, and it was let's see if my camera comes on even. There we go. Damn, that's dark.
Mine, I think, are both plastic. Let's see.
Oh, okay. There's also the IQ, but I don't think it has a balanced input.
Okay, mine says RSP2 on it.
Okay, so you got, this is the RSP2 Pro, and I think the Pro, the only difference is it has external clock input and it has the balanced on it.
Oh, mine has the clock inputs also. It doesn't have a metal case.
Okay, that's the Pro version. That's been obsolete for quite a while, but they still support it at least. The only one they aren't supported going forward is the original RSP1.
And I actually don't even know what most of the config options do. I mean, I got this from Franco, and I kind of merged it in. It sort of works, but I'm not even sure what those options do.
Yeah, they're infuriatingly vague, so you have to fart with them.
Yeah, there's an A input, a B input, and then what appear to be balanced inputs, I guess, for low frequencies.
Right.
So, Phil, you're saying the one that has a balanced input is an RSP2? Or is it an RSP Duo?
RSP2 on it. No, it says RSP2 as in.
Well, the Duo.
Okay, yeah, the Duo is newer than the 2.
Yeah, I have a Duo here somewhere, and I don't think it has a balanced input, but I might be wrong.
Yes, it does. Well,
okay.
It's not a balanced input. It's a high impedance input.
Oh, that's right. That's
three terminals on a green strip.
Right. Yeah, that's the high impedance input.
Yeah, that's it. That's it.
Right. Okay. Yeah.
And then there's the RSP DX.
Right. I think the Duo replaced this, but the Duo is actually a true dual input. And the interleave.
Dual tuner.
Right, and they're actually synchronized in interleave. So if you wanted to do what Glenn does and actually get two antennas and make sure they're always in phase with each other. Yeah. That is one claim to fame that they have, is they have something like that.
What is the 2 then? It has multiple inputs, but I can only use one at a time?
I don't know. I think that's
I don't remember the 2. I never tried one.
I think
had an
I hooked an
RSP1A,
antenna up to
Duo, and a DX.
All I know is I hooked an antenna on A input on this one, and I used Franco's config file, and I heard National Weather Service. That's about as far as I got with it.
Right.
Using config file. So.
Right. I don't think it has a dual tuner. I think only the Duo does. So I think it's just A and B and C. I think you can select the antennas independently. I think the high Z is attached to one of the A or B. I don't remember which.
Allen or something. Okay. I mean, the lack of information on this thing is maddening.
Yeah, it is. Yeah.
I wasn't inclined to spend a lot of time on it anyway, but I'm happy that I got it working.
Yeah. Okay. I'm just looking here. Yeah, it has a. Oh yeah. Okay, that's interesting. I just found the block diagram, and port A and B are just, you know, there's an
Oh, where'd you find that?
on their own website.
Oh, all right.
Right, just the block diagram. And the high Z port, according to this, bypasses all the filtering, which is weird.
Oh, all right.
I didn't remember that. I don't know why you'd. I guess you would use that for maybe the same thing a red pitaya is used in the lab or something. I don't know.
Okay.
I don't know, but yeah, the Duo is only one with the dual
Yeah.
dual acquisition.
Oh, they have a whole bunch of entries that are discontinued, including the RSP2 that I have. All right.
Right, right.
All right.
Yeah, yeah. The 2 is sort of a bastard child, I guess.
Yeah. Well, I bought both of these a long time ago before I realized how poor the support was, and I kind of tossed them in the shelf where they.
Yeah, I mean, we use them. That's our main receiver at the Utah SDR,
Oh,
the
okay, well,
public-facing stuff. They work fine for that. Although one of the things that they do not have is good input filtering. So they have they have that problem when you do a what do you it's like the Taylor detector, where the third harmonic is like 20 dB down, just because of geometry or symmetry. So what that means is that if you are listening around 80 meters, you hear 20 meters upside down. It's only about 3 S units down.
Yeah.
Or 4 S units down, because they have a filter that goes from 2 to 12 megahertz, and
yeah,
that's way too big. That's they should have octave filtering or close to octave filtering.
yeah.
And I didn't discover that until Rob had when Rob had the web SDR in Maui. I was
Yeah.
in the middle of the day. I was hearing all these signals on 80 meters, and I thought, "Wow, that's amazing." Why am I hearing out these 8 signals? They're lower sideband too. Then I started.
Right, they would be, wouldn't they?
Yes. Then I tuned in on the QE. They were all gone. Then I did a do, and then did some math and figured out what the hell was happening. So I had to build a special low pass filter that I sent over to Maui with Rob one time.
Yeah.
Or actually, I had his Gardner Jerome
Yeah.
Jerome put it in on the one receiver, and that fixed it. I blogged it, of course, but but anyway, that's. But I never know. We never noticed at Utah because we put band specific filters in the front of all the receivers anyway.
Yeah.
So.
Yeah, what's frustrating about these guys, they have all these specs, but because they kind of expect you to use their software, the specs don't really include enough detail for a guy like me. They say, okay, IF mode, 0 IF, all IF bandwidths, low IF, IF bandwidths less than 1 point. I don't know what that means. What do they mean by 0 IF and low IF? I don't know what that means.
So like most of these IQ things, you know, this is essentially down converts IQ to DC. These have a very narrow 0 hertz hole. It's only like 50 hertz wide. But of course, if you're trying to do AM or FM, you'll get all kinds of distortion if you land that right in that hole. So that's all they're doing is the low IF always shifts it, because on their software they disambiguate all that for you.
Yeah. But what I really have is a 0 IF receiver with a spike in the middle at the carrier, is what that really means.
Well, there's actually no carrier, but you have a hole rather than
well, at the LO is what I meant.
Right,
and
right.
It's up to me to then suppress the other image. That's what that really means, right?
No. I mean, it comes out IQ, so there's really, you know.
Well, but is there any filtering of the image, or do I have to do all the filtering of the image? I mean, I know how. I just need to know that I have to do it.
No, there's no image because it's IQ. I mean, it's complex.
Well, what I mean is that if I'm only interested in, let's say I park the LO at 148 megahertz. So
Okay.
I want to get 2 meters. Okay.
Mm-hmm.
What gets rid of this stuff above 148?
Okay. I mean, if it were me, I'd park it at 146.
Well,
then you'd be able to tune 2 meg up and down, and then it wouldn't be a problem.
Unless I have a signal right at 146. So I don't know what they mean by zero IF versus low IF.
Okay, the low IF. So what they do in their, if you leave it up to the API, they do the tuning of the local oscillator to never place the middle, the
Right.
the middle of it
Okay.
at the same place at that 0 hertz hole. So what I think you get out of your IQ is offset. So you don't have that 0
Okay.
hertz hole. So you'd see it, however, you'd see it. I don't know if it's above or below, but you'd see the 0 hertz
Okay.
hole if you looked.
Now,
your IQ.
is there any hardware filtering that's taking out the image on the upper side of the LO, or do I have to provide all that in my?
No, my understanding is all they're doing is just shifting the tuning for you.
Ah, that's all.
I think that's all they're doing.
Okay. All right. Well, I mean,
because I mean the lowest sample rate these do is 2 megasamples. So what you get out of the API has already been cooked.
okay.
So I mean, so whatever sample rate you get, I mean, I think, we wrote a driver that
Okay.
custom driver we
Okay,
use.
that explains why their
Right.
human is burning so much CPU because it's doing all that. All right.
Yeah, so that's one of the things. So like we use 768 as the sampling rate, and this thing
Yeah.
has to run at 3072. And
Okay.
we don't do the IF offset because all I do is like I'll place the little 0 hertz hole right between the sideband and the CW portions of the band.
Okay.
But nobody's going to be anyway. I kind of cross my fingers. And if there is anybody, they're sure as hell not going to be running anything with a carrier.
Yeah.
So you kind of have to go on faith. You just try to place that
Okay.
hole.
All right. Because not
It's
all
really
radios work this way. You know, the AirSpy R2 was sort of like this, but at least I had some help on that. I had what's his name? Hassan, what's his guy? The guy in Paris who kind of does all the what's his name?
Is he got the French guy that wrote the driver?
Yeah, he's French, but he's got an Arabic name, and he lives in Paris.
I think I've seen that show.
I've not met him. He's invited me to visit if I ever get over there, but he was really helpful in helping me with everything I needed to know to do what I wanted to do.
I think
realized
isn't that the same guy who did the open source, worked on the open source driver for the RSP as well?
Maybe
the Merrick's driver. I think the original Merrick's driver, which is it's somebody reverse engineered, was originally done by a Polish guy. Then I think it was expanded on by a French guy. I think. I may be getting things confused.
I know he's in Paris because we talked for a while, and I finally pieced together what they were doing was in their driver library. What they do is they take the output of a single A to D converter sampling at 20 megahertz, and they usually give you a 10 megahertz complex with the carrier shifted by a quarter of that sample rate.
Okay.
And it was actually he who suggested, hey, you don't need to do that because you're just going into an FFT anyway. You could bypass all that. And that's when I got, oh, yeah, he's right. All I need to do is support either a real or complex input, and I can handle anything.
Right.
And I can bypass a lot of processing. And that's the only way I'm able to do this in real time on a Raspberry Pi 4. So I thought that the way these things work is that there is a analog, basically analog phasing decoder, whatever you want to say. Anyway, the IF at which they're coming out is too low for them to use conventional hardware filtering. So they must be doing an analog phasing type mixer that gives me only the lower sideband. And then they digitize that with a single A to D converter, and that's what I get out of the AirSpy R2. And it seems to work well.
I think what they do is actually there's a decent block diagram on the AirSpy.
There is? Where?
On the website. Let me find it.
The AirSpy was another one where I don't feel like I would have gotten very far without his help.
So are we talking about the RSP or the AirSpy when you were just talking about?
What I was just talking about was the AirSpy R2.
Okay.
Which is right now my preferred UHF VHF. I have a bunch of them.
Okay. Let's see here. Yeah, somewhere there was some of the air spies actually have a block diagram that shows everything.
Yeah, and he's still selling them, still making them. He's got a web page on it, the AirSpy Romeo 2.
But I don't know.
It does say he uses a Raphael R820T2 or 860, which I think is a
Yeah, the 820 is the one that's been discontinued for years. That's what the RTL SDR V2 is all used.
yeah. And I think the 860 is functionally the same. And
Almost.
And a high quality oversampling 12-bit ADC and a state-of-the-art DSP resulting in up to 16-bit resolution in narrowband channels. But when he says that, I don't know, is he talking about DSP running a computer or inside of his box?
I think he's just oversampling the shit out of everything.
Yeah.
I mean, I think the SDR play folks kind of make a similar thing, where I mean it's a 14-bit A to D, but if you're running at 768 kilohertz,
Yeah.
you're really sampling at 3 meg. You can kind of claim that's
close. Oh yeah, that's going to be true regardless of where the DSP is done. But when I see this, I don't know. Are they talking about DSP is being done on the host computer or inside of their box? I never know. I mean,
there's no smarts in their box.
I
don't think there's a. I don't think there's a processor in the box.
Okay, well then something is getting rid of the image because I know where the carrier in the AirSpy R2, the model I have of the thing is that it's a high side injection mixer with a single A to D channel coming out of it that's sampling at 20 megahertz.
Okay.
And it gives me everything from about 600 kilohertz below the LO to about minus 8.4, I think.
So if you look at there is a block diagram in the RSP Discovery.
RSP.
Okay. I'm not RSP. AirSpy Discovery. I have RSP on the brain.
Okay, because I think that may be a newer unit of his. The AirSpy R2 has been around a little longer.
Right, and that shows a pair of A to D converters.
Okay.
And it is
a different architecture.
It actually shows an MCU in there too.
Well, I know that there's a processor in there that's controlling it because something has to program the synthesizer. Because in fact, he gave me the microcode that did that so that I could shadow it in my own code and get the actual frequency that the synthesizer was producing, so I could get precise. That's my pet peeve about a lot of these units. They all claim they can tune to 1 hertz steps, and they're not.
Well, but anyway, so essentially what the AirSpy HF Discovery has is just a polyphase mixer on it.
Okay, I have one of those too, but I haven't dug into that one. I just use it as it's given to me, and it gives me a complex.
Right, and if you use
stream it up to like 910 kilobits.
And if you use a polyphase, aka Talo mixer,
yeah,
then all you need to do in that case is low pass it, and you're probably okay.
Yeah.
And I wouldn't be surprised if that's what they're doing in the R2, but it doesn't. There's no block diagram of the R2 on here.
Okay, the Talo, that's just that multiplexer, the switch, the 4-way switch with the capacitor.
Right, or anyway switch, whatever. Yeah, and that it does what it says on the tin.
I think the very first of the Flex radios did that, I think.
Yeah, they well, yeah,
a long time ago.
Yeah, and it was actually patented in the 70s.
Oh wow, a lot time ago. Okay.
I think Dan Taylor, I think he may have patented it or something, but it was quickly discovered after I saw that. They talked about it in QLEX maybe about 20 years ago.
Yeah, I remember he wrote the article.
In a follow-up, somebody immediately produced a citation for a patent, which was the same damn thing, but from the 70s.
Good. Yeah, it happens all the time. Okay, so I'm trying to figure out when the R2 then, who is getting rid of that upper image for me? Because I am only getting a single real stream. I handle as a single real stream at 20 megahertz. Normally, what his library gives me is a 10 megahertz stream that's complex, and he has to do a half band filter to do the sample rate conversion, and that chewed up a lot of time. And by getting at the raw A to D output, I was able to bypass all that and save a huge amount of CPU time and allow it to run in real time on a Pi 4. But something is still getting rid of the upper image on the other side of the LO. And I assume that that was done in analog hardware.
Well, probably. So I think it might be the same sort of thing that is done in the RTL SDR. Like the RTL 2832 is the dual, it's a quadrature 8-bit A to D converter, but they're not really using it in quadrature mode on the way we hams use it. What they're relying on, so as you probably remember, the Raphael tuners tuned to something like 5 or 6 megahertz, and they're relying on the Raphael tuner chip to give you a window.
Yeah.
And so that effectively does the anti-aliasing filter for you. So because they are the 2032 chip is sampling at 28.8 megahertz.
Okay.
So they're only typically putting it in, the center frequency is usually somewhere around 5 to 8 megahertz is my understanding, is the way they usually use those. So they're kind of relying, if they're using a Raphael chip on here, they're probably relying on the fact that that does the heavy lifting for the filtering. And so that only, because that has a decent-ish bandpass filter of its own on the IF side of it.
Okay.
So I'll bet you that's what they're doing.
And that's what's getting rid of my upper image.
Right. Because it's not there. I mean, they're just putting a bandwidth limited signal into the A to D converter.
Yeah, I mean it's bandwidth limited by the 820 chip, I thought, because
Yeah, I think it is.
because it's designed for digital TV, right? So it's giving me an 8 megahertz TV channel with a roll off on either end, and I assume that's what I'm getting in all these devices.
Right, and the Raphael chip is actually programmable with bandwidth.
Yeah, well, I can go either 6 or 8. So you always
yeah, it does a bunch of things. Yeah, and I think that's I'm pretty sure that's what they're doing.
Okay, well, something is getting rid of it because I don't have to.
Well, yeah,
I
it wouldn't.
actually tested it, but it's.
I mean, consider the case of the RTL SDR. It's gotten rid of because it's not there because the Raphael chip gets rid of it for you.
Yeah.
I mean, because it's bandwidth limited below Nyquist coming from the Raphael tuner in the first place.
Right.
So it just ain't there.
Okay, I'm gonna have to. I'd love to see a diagram of this.
Yeah, it would be interesting too. I don't see where it says it uses a Raphael tuner.
Well, I mean, the spec sheet at AirSpy R2 says, it says 12-bit A to C at 20 megasamples per second. And then right underneath it, it says 10 megasample per second IQ output. Well, that's not what it's producing. They're blurring what the hardware does with what their driver software does. Now, their driver software is open source.
Mm-hmm.
That's an app package. So I was able to look at that and I was able to figure out how to get it to send me the raw A to D output at 20 megasamples per second, which I thought was coming off of some kind of analog part that is getting rid of the upper mixer output for me. Because I never had to worry about that. To me, it looks like a high side mixer with something that is getting rid of the image on the other side of the mixer, followed by a 20 megasample per second A to D. That's the model I have of it, and that's what seems to work. Now down here it says, up to 80 megasamples per second when using custom firmware. That's interesting. That's 4 times 20. I wonder if that means something.
Oh, there it is. I had to find the correct.
Yeah, because when they say specs, they're conflating what the box does, the hardware in the box, the firmware in the box, and the software and their driver it runs on your computer. That's all conflated. That's what always confuses me. IQ or real, 16-bit fixed, 32-bit float output streams. And I always want to just the most raw output I could get, because I felt like anything they do, I could probably do more efficiently, and I think I can.
That's telling. 10
Well,
megahertz
yeah, well,
standard
I mean,
item spectrum with view up to 9 megahertz, alias image free.
yeah.
That tells you a lot there.
Well, that's what I am getting. I mean, the thing is sampling at 20 megahertz. So what I get is the 10 megahertz below the LO, although I can't use the upper 600 or bottom 600 kilohertz of it, which I always assumed was the filtering and the tuner chip, because that's what you would need for a digital TV tuner for the roughly 8 megahertz channel bandwidth.
Right. The RSP is the same way.
Okay. All right. Well, that's good to know.
Yeah. Although the RSP at least does have some. It annoys me that it's hardware filtering, which is really low pass filters on the on the A to D inputs.
Okay.
They're not. They have some less than useful bandwidths for many ham stuff, many ham applications. Like
Yeah, the only drawback to this is that I can't get the whole 70 centimeter repeater segment band from 440 to 450. I have to pick a piece of it, but in most areas it's not a problem. In Southern California, it's all low and high out, so I can get all the simplex channels and all the repeater outputs.
Oh yeah.
On the other bands, I can get everything. On 6 meters, on 220, on 2 meters, I can get the entire band with one unit.
Oh, so California is high out then, huh?
It's low and high out. At least, in Southern California. I think it may be different in Northern California, but Southern California, it's low and high out.
Utah's low and high out, probably for the same reason that California is.
Yeah, it makes more sense actually, because it means that if it's the other way around, then your repeaters would have to be rejecting nearby 450.
Yes, yes.
So there's a good rational argument for doing it this way.
That's I know the guy that was first coordinating repeaters in the early 70s on UHF, and that's what he decreed. It's like, why the hell do we want to filter? Why don't we put the paging transmitter,
right,
megaway instead of half a meg or 2 megaway?
Exactly.
Yeah.
It may be different in Northern California. I think it's also different in the New York City area. I just visited an old friend of mine who lived there, and I was setting them up, and I think around there they use both.
So Central and Southern Arizona are low out, but Northern Arizona, like around Flag, is high out.
Yeah.
Go figure.
Yeah, I don't know why it isn't just one national standard, but everybody somewhere is always trying to squeeze me through more repeater pairs out, and that's how this stuff happens.
Right. Yeah.
Even if most of them are never being used anymore.
I'm just looking here. Let's see, RA20 LPC. I think LPC 4370 isn't that the processor? I'm not the processor, isn't that the inverter?
What are you looking at?
I'm looking at the. There's a picture of the board.
Of the R2? Yeah, I'm looking at the same thing. 4370, yes.
What is that? Is that the AD?
I don't know what that is.
LPC 4370.
And all the other parts I recognize.
Oh, it's a Cortex. It's a 32-bit MCU.
Okay, that's just the thing at controlling. Okay, that's setting up the the clock.
Oh, it's the A to D as well.
Oh, okay, all right.
It has a single 80 megasample 12-bit A to D on it.
All right.
That answers your question.
About 80 megahertz, yeah.
And also, it has one A to D channel.
All right.
Has 112. So that's what they're doing. They're using the Raphael chip. Oh, I see what they're doing. Okay, so they're using the Raphael chip to give you this bandwidth limited stuff around 8-10 meg maybe, and there wouldn't be any high side to get rid of anyway. And they probably, because the
what's getting rid of it? I mean, there's going to be a mixer image. What's getting rid of the mixer image is what I want to know.
Yeah, but the Raphael chip is doing the magic.
Okay, that's what I was getting at. So, and it must be doing it in an analog phasing fashion, because I don't know that the 820 has anything digital on it.
I don't think it does. I don't know how the 820 works.
Well, that's what I'm getting at. Yeah, I think the 820 must have some kind of phase, complex mixer.
I think it does. It probably
yeah, okay. That's
it probably has the, like they used to use in C-band satellite all the time.
uh,
The image canceling mixer.
oh, I didn't know that. Okay.
Yeah, that was the trick they did. They did an image canceling mixer on the PC board, and they only practically ever got 15 to 20 dB of image
Yeah.
rejection, but that's enough to
Yeah.
mostly
An image
quash your
canceling
noise.
mixer is just a complex multiplier.
Correct. So
Yeah.
so that's what they're doing. And also, I'm looking at here on the board. They have the MCX connectors that go directly
Yes.
to the processor, and that's how you would probably get the 80 meg input.
Yeah. Actually, it says ADC N1 and N2, but you say there's only one ADC?
Well, I'll bet it's muxed though.
Oh, yeah. Well, that's not very useful.
Right. I mean,
I can only use one of the
without
three.
explaining why somebody said somewhere that with the right firmware you can get 80 megasamples. Well, if they provide
Right.
provide a backdoor around the RF. In fact, you notice there's also very telling there. You notice there's an RF out thing that's RA20 T2 LT RF loop.
Yeah. I've seen some information on the 820T, so I know what that is.
And
That's
I'll
not
bet you there's probably just one of those single pole, single throw switches on here. And you
yeah.
can switch that out and you could actually run it outboard if you want separately, if you were so.
Yeah.
So yeah, so this is just so apparently this Cortex, whatever it is, it's a Cortex M4 plus. So that would be able to do, megabits of processing, and probably would be more than grunty enough to generate, megahertz of IQ. Just
Well, no, they're not like I said, they're not generating when he gives you IQ, it's coming out of the driver running on your computer,
right, but
burning your CPU.
okay, but the Cortex M4 would probably be grunty enough to do that if the USB bandwidth was adequate.
So, because it's actually not trivial. I mean, to convert real to complex, you have to do a half band filter because you're dropping the Nyquist rate is half, even though the
Well, you can fudge that a bit if you don't have anything to if you don't have any. I mean, if you bandwidth limit your input, you could kind of fudge that, can't you?
oh, I see what you're saying.
Yeah. If there ain't something there that you need to get rid of.
Anyway, I'd study the code in his library that I'm not using, and it does have a conventional FIR half band filter.
Okay.
That looks like it uses up a lot of probably uses a lot of CPU, and I was able to bypass all that.
Oh, okay.
Yeah, because I can do a more efficient job. I mean, I want to get everything into the FFTW as fast as possible. He doesn't seem to like it. He never explained why, but I think it's probably because it has a GNU license on it.
Oh, okay.
Which is fine with me because I put a GNU license on all my stuff. So I have this advantage. You see that he doesn't have because he's trying to make money off of this.
Right.
Although I don't understand why that would be a problem because he does open source his driver.
Right.
I don't know why you couldn't use FFTW, but he seemed vague about why his reasons for not liking it.
So I never really looked at the AirSpy before, but now I see why it's around $200 is where the RSP is around 120, because there's a hell of a lot more going on it.
Yeah, well, I like the AirSpy. I mean, I bought a pile of them now. I have one up on the mountaintop that's receiving the whole radio sign band.
Right. And I think the Raphael's limited to 8 megahertz, but it's not very sharp. Something
That's
like
right.
that.
But that's enough to cover a whole bunch of bands, right?
Oh yeah.
One at a time. That's what I'm saying. I can get all 2 meters, 6 meters, 220, and at least the whatever repeater output section you're using on 70 centimeters and get them all at once.
Right.
Per band. I have 3 of them right here at home. You know, I've been doing this for 4 years now, recording every FM channel I can get. I dropped 6 meters and 23 centimeters because there didn't seem to be much activity on them.
Right.
I do get 10 meters, so that just comes off of my RX888. So occasionally I'll hear 10 meter repeaters come through. Frustrating about 10 meter FM is usually they fade in and out before there's ever an ID.
Right, but if you hear a gunshot, you know it's when it is.
Huh?
There's a repeater in the Adirondacks, the one by New York. and and like I forget which way it is, but it's has at least two inputs: the 2 meter side and the 10 meter side. And one of
Yeah,
them's courtesy tone is a doorbell, and the other one's a gunshot. And I don't remember for which band it is.
I never heard of that. Well, the ones I usually hear are coming from Portland, Oregon, to that area.
Okay.
Yeah.
Yeah. Although the gunshot doesn't sound like a gunshot, it sounded to me like it was just a really bad squelch tail to me. But then I was listening to it and somebody said, "Oh yeah, that's the gunshot." And
Well, I'm recording them all. I might have them for all I know in
oh
my
yeah,
house. I just
I
go
think
back
that's
and
the
look.
I think that's the 6.2 repeater, the one I'm thinking of, the one in
Okay.
New York. It's a big one. You hear the Brits in it all the time. It seems to have it must have multiple receivers.
Yeah. 29.62. I can go back and listen.
I think that's what it is.
Okay.
It's near the top of the repeater.
Yeah.
Near
Well,
the,
that's where all the FM outputs are. And
right,
the
right.
separation is only 100 kilohertz.
Oh, that's right. Yeah.
Yeah.
Yeah. Yeah.
Oh, and 10 meters is open, man. I see beacons everywhere.
Oh, yeah. I
Is open.
I recently added beacon subband to the CW skimmer we're running at Utah, and
I need to get something like a CW skimmer going. I just want to grab everything, and I need a skimmer.
yeah, I don't. The world is crying out for an open source skimmer that works worth a damn.
Well, something based on AI machine learning would probably be the trick.
Right. The current one is the one that's done by the Canadian guy that's been around since like '04, and was last touched in 2014 or something like that.
Well, like we said before, for repeater eyes, it's probably good enough.
Well, that's the one that the CW reverse beacon network uses.
Yeah, and you've told me how bad it is, although it's still good enough.
It's good enough by bulk. There's also the one by the Russian guy. There's the DD STC, I think, and that one's not open source. But one of the bigger problems too is they both run on Windows.
Oh God, yeah, never mind.
Which so I mean, in northern Utah, we have to. I mean, we have to fight that. It's a hell of a kludge, but it works. I'm going to try using the Russian one, which is at least currently updated and seems. So somebody apparently decompiled the Canadian one enough and discovered that it ties the decoding to just or ties the processing to one core at a time.
Yeah.
It doesn't do multi-threaded decoding. And there's something that happens that we can't even run it on a virtual machine. We can't get any more instances of it running with a virtual machine than we can with the running without virtuality.
Yeah.
And I don't know. We don't know what it's doing. It's thrashing a lot of I/O or RAM or something. So what happens is the processor runs out of memory bandwidth, not processor bandwidth, but memory bandwidth, for as far as we can tell.
Yeah.
And it's just badly designed. Whereas supposedly the Russian, it's actually Ukrainian, the one that's the SDC or whatever, apparently is at least better designed and seems to work supposedly about as well, although it doesn't really work. Let's see.
Come up with you find a good one. Let me know because I would love to put something in the KNIQ radio because I've told you I had this idea where you could just turn on a box in some town and would just have it immediately inventory all the repeaters you could hear.
Well, looks like Scott asked, "Can you knock out the core affinity by hacking the binary?" Maybe, I don't know.
Maybe, but who wants to do that? At some point, it's just not worth hacking somebody's binary. It's more fun to just redo it from scratch.
Right. I mean, at this point, it's turd polishing.
And for me, that threshold comes pretty early when I get tired of hacking somebody's code, and I just say to hell with it, I'll just rewrite it from scratch.
There's apparently some people. I forget. There's a decent reverse compiler that's intelligent. If somebody said the name of it, I'd know about it. Yeah. But apparently somebody.
I have very little patience for that kind of stuff.
That's it, Gerda. That's the one. Yeah, you can find somewhere on the forum where somebody apparently fluent in Gerda put it in there to discover that it was locked to a core. And that fit with the observations. and it doesn't seem to, it'll use more than one core, but it doesn't seem to use things efficiently.
Yeah.
So it doesn't matter if you have a like a quad core i5 or i3 or a fairly new 5800 or 5850
Yeah.
4 gig. You can't get any more than about
Well, it's
10 or
Rob and I
so.
are discovering, memory bandwidth may be our limiting factor too.
Yes.
Um,
Yeah.
so we think I have all these cores and they're all so fast, but they all have to talk to the same memory and often to the same level 3 cache.
Right.
And that often puts a limit on what you can really do with one computer. So I'm not, I think if I'm going to tell people what to get for K9Q radio, if they want to monitor multiple bands, I'm going to tell them, look, you might be better off getting multiple cheaper machines than one big expensive one.
Right.
They also have separate USBs, which is another, advantage.
Right.
That's why one of the reasons I use multiple Raspberry Pis. The Raspberry Pis are not exactly the best number crunchers around, but I like the fact that one can crash and the others keep running.
Right. So I guess that's what you use on your
Yeah,
hard
I'm currently using. I've thought about replacing them because it's actually building a cluster of Raspberry Pis is kind of a pain. You got to provide power for each one. You have to cool each one. They're just not really designed for that. Raspberry Pis are great for embedded things, but if you need more computing power, just buy a faster machine. I mean, Rob has certainly shown you can do that. You buying these mid-range Intel or AMD machines, you get a pretty good bang for your buck.
Yeah. Yeah, it'll be
Often better than what you get with Raspberry Pi.
well. Yeah. So I guess what you're looking is a lower precision floating point for the FFT.
Well, I've been encouraging Rob to think about this for storage. I think 32-bit floating point is overkill for what he's doing, and I'm also thinking about it might be a way to boost bandwidth in what I'm doing since I don't really need 32 bits either, especially considering what's coming from the A to D is only 16-bit linear.
So you're talking about what 32-bit integer or something, or
well, no, 16-bit integer. I mean, there are integer FFTs around. Before floating point became so easy, a lot of stuff was done integer. With integer, you do have the problem of scaling. The big problem with building integer FFTs is that as you go through the butterflies, things have to be rescaled. Floating point, you don't care. It got so much dynamic range, it just handles the problem itself.
right. So as far as that goes, is the do processors? I don't know what processor hardware does these days.
They do integer vector arithmetic. Would
they do single precision?
Yeah.
Well,
what's happened with each generation of vector instructions at Intel, they first come out and make them work on single precision floating point, and then they come out with another version that can also do the same instructions in the same size registers on integers. That's usually the next revision. Like when SSE and SSE2 came out, which has been a while now, SSE introduced a whole bunch of 128-bit registers. When SSE2 came out, they allowed you to use them all on integers as well as floating point. And also they allowed to do on 64-bit doubles. So their first priority was to do everything, was to support 32-bit floating point, which is what most scientific computing uses, including us, what we're doing. But people also want to be able to vectorize integer arithmetic, which I found useful because I used to do a Viterbi decoder, which is integer, small integers, in fact, 8 bits.
Right.
And at some point, memory bandwidth becomes your limiting factor. So, just because the CPU is fast, it doesn't mean you necessarily want to use it that way. Because especially with something like float with Viterbi decoding, the memory bandwidth starts to become a limiting factor. 10 years ago, 11 years ago now, I did a Viterbi decoder for a constraint like 24 convolutional code. If you know what that means, it was just absurd. I mean, nobody had ever thought of using a Viterbi decoder on a code that large, even then. But I did it because I was helping rescue this spacecraft that had been in solar orbit since 1978.
That,
And
that was the IC spacecraft.
ISE-3, yeah.
Yeah, okay, I remember reading.
Yeah, and the attempt was unsuccessful because the nitrogen propellant or pressure had leaked out. But my part of it worked. I did the decoder for it, and we got the data from the Arecibo dish, and I was the one who decoded it, and that all worked. And I kind of did it this way, just kind of on a self dare. I mean, could I make it work? And the answer was, yeah, I did make a Viterbi decoder work at this ridiculously long constraint length for Viterbi decoding, but I was limited quickly by memory bandwidth. I could not make it run at faster than a few hundred bits per second.
I was just going to ask, what was the bit rate on a 70s satellite at long distance anyway?
Well, I mean, it was originally the codes like that were being used. It's just you didn't use Viterbi decoding because Viterbi decoding's complexity goes up exponentially with the constraint length.
Right.
And
Yeah.
the longest that's generally used in everyday use is constraint length 7. So going from 7 to 24 is quite an increase in complexity. You use other suboptimal algorithms. You use Fano decoder, like what's being used in Whisper right now. They're using my Fano decoder I wrote back in the mid 70s. But he can translate it from C to Fortran, of all things, which I still chuckle about because, hey, he's an old school scientist writing Fortran, right?
Right.
And that's constraint like 32, which is absurd to do with the Viterbi decoder even today. I think you'd probably get like 1 bit per second out of it. But then, hey, Whisper's not that fast either.
Right.
But Viterbi decoding has the advantage of being optimal. It's going to give you the right result every time for a constant amount of work. Sequential decoding will usually give you the right answer, but the amount of work can go up basically unbounded as you get into noisier signals, which is why one of the reasons the Whisper decoder is so slow, is that he's often trying to push this down below the threshold where the complexity goes basically to infinity, or at least becomes unbounded, which is why his newer codes don't use sequential decoding. They use low density parity check codes, which are much newer technology and actually also get closer to the Shannon limit. But when he started, he started JT65 and Whisper a long time ago. So when they started, he used what he had, and it was my coder, really. So I did this back 10 years ago, basically as a self-challenge. Could I make this work? And actually, as it was far away from Earth, it was okay because the data rate was limited by the link anyway. Even with the Arecibo dish, they couldn't run it at like like a kilobit per second because the links didn't support it. But as it got closer to Earth, they goosed the data rate up. I could no longer keep up with it with my Viterbi decoder. So I implemented a hybrid decoder. I would do a sequential decode, and only if that failed would I then, throw the Viterbi decoder on it. And that actually worked pretty well. So it never had any problem once I got my code working of getting the data out of the thing. Unfortunately, the propulsion system was not in good shape.
Yeah,
so watched it go flying by. All we needed was about 15 meters per second of delta V, and we could have captured it back into the Earth-Moon system. To do what? I don't know, but hey, it would have been a great hack.
Yeah, I guess I've heard suspicions that there are other spacecraft out there for which the similar opportunity might present itself.
Maybe, yeah.
But I haven't heard it that they actually are.
The problem is the propulsion systems are probably not in good shape. Either they're out of propellant or they're out of pressurant.
Right.
And then Dennis Wingo, who started this whole thing, and he and I had a falling out because that guy is let's say he's a climate change denier, put it that way. Yeah, so actually our falling out was over whether or not a solar cell was a heat engine. I can't believe that.
Whether a solar cell is a heat engine.
Whether a PV photovoltaic cell was a heat engine. I said, of course it is. My authority is no less than William Shockley, one of the inventors of the transistor. I even cited the paper. Somehow he got offended by that. So, People get offended by weird things.
Yeah, that's a very nerdy argument to even.
Very nerdy argument, yeah. But
Yeah.
I wasn't about to back down something I knew to be right just because he threatened to defriend me, so he did.
The nerdy you are, the more pedantic.
Exactly, right. Well, he was saying things like, "Well, actually, PV cells operate according to quantum dynamics, and that's newer physics than thermodynamics." And I don't know where he was coming off with that. I mean, come on. I mean, they're both physics. They're both laws. They're both still in effect. They don't supersede each other.
Right.
But I mean, a PV cell is a heat engine, right? I mean, the sun glows only because it's hot.
Yeah, I guess.
Yeah.
Yeah.
I mean, it came out of an argument where I'd said, I think I was saying something like that the thermal power stations that we built here in California were the experiment that failed because we didn't know how good photovoltaics were going to get. And that's how solar power took off, is the photovoltaic power, not thermal. However, the laws of thermodynamics say that we could make solar power up to 95% efficient if we knew how, because it's a heat engine. The sun is at 6,000 Kelvin. Ambient temperature here is 300. The Carnot limit for that temperature difference is about 95%. So we could make solar power 95% efficient if we knew how, but we don't. And that's what started this whole argument. It went downhill from there. Oh, man. People get their heads wrapped around weird arguments sometimes.
Right.
Yeah. But I never thought physics would become political. Science is science, it just is. It's not political. It's not politics. Yeah. Well, remember the Germans wouldn't accept relativity because it came from a Jewish physicist.
Yeah, look.
Yeah.
Yeah, I mean, yeah.
We're weird species.
We're still around.
Somehow we are for now. I don't know how much longer, but anyway, I'm gonna go finish unpacking and go to sleep.
Yeah, sounds like a good plan.
Good talking to you. If you do run into any more problems with level calibration errors, let me know.
Right. I was that question came up in the Monday meeting prior.
Yeah, I think I missed that because I was in Maryland.
Right, and I think whoever is doing the archiving of the 32-bit WWV stuff, I mean, if you look at it right now, it's scaled in linear A to D units.
Yeah.
And it should be scaled in power. And it'd be nice if it could be scaled in absolute power, assuming calibration. I mean, you know what I'm saying? I mean,
from the antenna input. Yeah, I can't answer for what happens ahead of the antenna terminal.
True. But at least you have a place to start. I mean,
I have a place to start. Yeah.
Right.
And at the very least, I should definitely be calibrated from the A to D output of whatever my front end is.
Right.
Yeah, I should be able to do that.
Right. Yeah. And one of the things that might come up eventually is, I don't know how practical it would be, is that with real world filtering in front of A to D converters, you end up with a gain slope or an attenuation slope.
Sure.
How one would, if one wanted to do so, how would one calibrate that out in terms of power readings?
Yeah.
In readings, whatever.
Well, you got the good signal generators. I don't, so that's kind of up to you, isn't it?
Right. Yeah. Well, on my blog, I actually did make rough measurements of, I mean, up to about 35 meg or so between with the bias T still in, between 1.5 and I think 35 megahertz is within a dB as far as I can tell.
All right, I guess I got to check your blog. I haven't looked at it.
Right. But I haven't checked it. But I only tested it with a sample of n equals 1 units, and I have 2 units, so I can do.
Yeah.
I have 2 units, so that's at least something. But I would imagine, unless components are really crappy, they're going to probably be better than a dB between each other,
Yeah.
I think.
Well, hey, going from 0 to 1 is still an infinite increase in dB. So,
Yeah, that's true.
yeah. So, yeah, if you could characterize a bunch of these front ends, even approximately, that would be very useful.
Yeah, I can characterize what I have.
Yeah, because then I can start putting in some of these gain adjustment factors, like the minus 1.4 dB. That came from Jim Lill,
Okay.
W2ZKD. He did some measurements, and I think the 1.4 dB probably is close to the losses you saw in the front end of the RX888.
That's probably about right. Yeah.
Yeah, which made me think that it's probably not a coincidence that that A to D produces full scale with a 0 dBm input. Probably not a coincidence.
I don't know. I've never actually run the numbers because I don't know. So there's a low and a high pin on that
Yeah,
particular A to D, and
yeah,
I don't know
yeah,
what that's set to, or if it's even, or if it's even tied to the FX3 or not. That may
yeah,
be a Franco question.
yeah.
But the thing is there's I think you're better off. I mean, it makes no difference in in noise floor whether or not you have that set to low or high.
Right, right. It's whatever's convenient to work with, probably.
Right, and it's what is it, like a 2.4 dB difference or something like that. It's I don't
It's
know. It's
not that big, yeah.
no.
Yeah,
I don't know what the A to D on that is set to, or if it's strapped to anything.
yeah,
I do have one that's stripped down a bit, one that was I couldn't repair, and maybe I'll try buzzing it out, see if they've tied it high or low, or see if it goes to an FX3 pin. In which case, Franco would be the one to ask if
yeah,
that's a settable option.
yeah. I expect he's busy in other things. I haven't heard much from him lately.
Right. Yeah.
He's already helped a lot, so I don't want to bug him more.
Right.
All right. Good night, Clint. Good night,
All right.
everyone.
All right. See ya.
Take care. Bye.
I'm gonna go away too. Bye.